So, if you, like us, have spent any time playing around with modern generative AI, you probably know that feeling, right? That kind of cognitive dissonance it creates.
Oh, absolutely. One minute it's giving you this amazing, like, flawless technical analysis.
Yeah,
And the
yeah.
next, it's just invented a historical fact. Or maybe a citation that looks real, but, well, just doesn't exist.
Exactly. It's statistically brilliant, but then it seems to completely miss basic reality sometimes.
And that's really the core of what we're looking at today. It's that gap, isn't it, between systems that are incredibly good at statistical language prediction and systems that actually achieve genuine meaning awareness. Our sources today really dive into this, exploring, well, the philosophical side and the architectural solutions needed to maybe bridge that huge chasm.
That's the mission for this deep dive, then. We're getting into that pretty complex intersection of the philosophy of language and artificial intelligence. We'll look at some of the history. Those critiques of the early AI language systems define that really critical failure point, the grounding problem.
Right.
And then explore the two main paths forward people are talking about. These things called hybrid cognitive architectures and the philosophical angle of hermeneutics.
Sounds good. So maybe starting with those foundations, the ones that didn't quite hold up.
Yeah, let's do that. Where did the early ideas come from?
Well, to really get the problem, you have to look back at how AI language processing started. And it was fundamentally built on formal symbol manipulation.
Okay, symbols.
Yeah, the basic idea, and this goes way back, traditions like Aristotle's logic of classes, was pretty simple conceptually. Intelligence is just the syntactic manipulation of symbols, using fixed logical rules.
Right, so the meaning of a word wasn't really about how it connects to the world or experience. It was just a piece, a token that you can move around based on a set of rules.
Exactly that. Meaning was basically seen as like the collection of allowed operations you could use to transform a sequence of these tokens. And one of our sources, Dascal from back in '89, really pointed out the fatal flaw there. These classical AI systems relied way too heavily on what they called fixed epistemological frameworks.
Okay, fixed epistemological frameworks. What does it actually mean in practice? How does a fixed framework end up limiting a machine?
Okay, think of it like this. Imagine giving the AI a dictionary, right? But this dictionary is like sealed shut forever on the day it's published.
Okay. Static.
Totally static. It gives you a formal, unchanging definition for every single concept. But then the system just lacks any ability to, dynamically deal with context changing or how culture evolves or even just individual interpretation.
Oh, I see.
They basically assumed meaning was static. They kind of completely overlooked the fact that context is what really drives meaning in language.
And if you ignore context, what's the first thing that breaks down when you try to process natural language?
Well, you immediately hit problems with ambiguity and polysemy, where one word or even a phrase can mean multiple different things depending on how it's used.
Right.
These purely symbolic systems just failed to really grasp the contextual nature of meaning. And because they couldn't handle that cultural variation or, situational differences, their understanding was always kind of shallow.
Yeah, that makes sense. Our sources mention this idea of representational correspondence being a core issue, too. The idea that language is just a direct, static encoding of rules stored in these rigid ontologies.
Exactly. But real communication, actual human conversation, it's never that neat and tidy, is it?
Not at all.
Real communication is, well, it's dynamic. It's often contested. People negotiate meaning. Meaning gets created right there in the moment of interaction. You don't just pull it out of some fixed database.
So if you treat language only as that kind of static code,
you fundamentally cannot capture the richness, the nuance, the actual meaning found in a genuine conversation. And the inadequacy, it becomes really, really obvious whenever the AI bumps into language from a field it wasn't explicitly programmed for, or like when the situational context is totally new.
Okay, which perfectly sets up the sort of the central challenge that we're still grappling with today, right?
Yeah.
Even with these huge trillion parameter models, we're talking about the grounding problem.
Yes, exactly. The grounding problem. It's basically the main hurdle stopping AI from getting to true context-sensitive meaning.
And what is it? Fundamentally,
it's the simple reality that the machine's symbols, its words, its concepts, they're defined purely internally within the system without any real connection or relation to, say, embodied experience or sensory data or just plain real-world context.
So they're kind of unhooked from reality, floating in this big sea of statistical patterns.
That's a great way to put it. Yeah, floating in a sea of statistics, unhooked.
And the most obvious symptom of this lack of grounding, as Larghi and Datteri talked about recently in 2023, is that thing we all see, the dreaded hallucination.
Right, hallucination. That's when the model spits out text that seems plausible, grammatically fine, but is actually semantically disconnected from what the user asked. Or, just facts about the world.
It looks confident, but it's just making stuff up.
Pure invention, yeah. And it's a direct consequence of that grounding failure.
So, okay, if these massive language models have basically ingested, like, the entire internet, why do they still have this problem? Why do they hallucinate? It seems counterintuitive.
It does, but it's because they suffer from a really fundamental syntactic bias.
Syntactic bias.
Meaning they're designed primarily to reproduce patterns. To figure out that word X very often follows word Y in the vast amount of text they've seen. They're absolute masters of statistical pattern completion.
Okay.
But that process, inherently, it's focused on structure, on sequence, not really on context or interpretation or, meaning in the human sense.
So they can generate grammatically perfect sentences about, say, a historical event.
Right.
But they don't actually know if that event happened or what the words they're using refer to in the physical world or the social context.
Precisely. They lack that referential link.
It really sounds like the answer isn't just throwing more data at it or building bigger models. We need something more foundational, a different approach.
Absolutely. And that's what Larghi and Datteri argue for. They say we need to start integrating models of intentionality and context recognition, models built more on pragmatic and interpretative perspectives.
Teaching the machine why people say things, maybe. Not just what words tend to follow other words.
That's a good way to think about it, yeah. Getting beyond just the sequence.
Okay, so that takes us nicely to the first big proposed solution pathway. The architectural one, hybrid systems.
Right.
The idea being that the purely representational model, that static thing, it just has to be, well, abandoned or at least coupled with something else. Architectures that can ground meaning contextually and interpret it.
Exactly. And this is where these hybrid cognitive architectures, which Vadinský highlighted back in 2013, really come into the picture.
What's the core idea behind them?
They're specifically designed to try and mirror aspects of human cognition by deliberately combining two different kinds of systems.
Okay.
On one hand, you have symbolic clarity, that sort of fixed logical structure from the old AI days, but you combine it with connectionist plasticity, which is the more dynamic, fluid, pattern-matching ability of modern neural networks.
But wait, haven't people been trying to sort of bolt logical systems onto neural nets for ages? What makes these hybrid architectures really different? Is it just a better bolt?
Well, it's more about deep integration,
Yeah.
not just bolting them together side by side. They often use these structured, layered systems based on an idea called stratified perception.
Stratified perception.
Yeah.
How does that work?
Okay, think about how a human might read, say, a complex metaphor. At the lowest level, you've got the connectionist part, the neural net, maybe identifying the raw symbols, the letters, the basic grammar. That's kind of bottom-up processing.
Okay, raw data coming in. And where does the symbolic part fit?
Right, so that lower layer feeds its initial findings up to higher, more symbolic levels. An architecture like CLARION is an example. These higher levels then apply more abstract, perhaps fixed rules, conceptual categories.
I see.
But, and this is critical, those higher levels then feed information back down to the lower levels. They provide context. That's the top-down part of the loop.
So the top layer might say, okay, the overall context seems to be economics.
Exactly. And that context immediately helps clarify the meaning of an ambiguous word like bear or bowl down at the lower connectionist level.
Got it. So it's this constant two-way conversation between the layers. The system is figuring out semantics by looking bottom-up at the syntax, but also top-down from the overall concept or context.
Precisely. A continuous loop. And this offers a huge philosophical advantage, which is relationality.
Relationality.
Yeah, these hybrid systems essentially construct different worldviews or interpretations based on those constant relational cues flowing up and down. So meaning isn't fixed. It becomes emergent, fluid, because the system's understanding is built from combining multiple relational signals, not just relying on one static definition.
Okay, so the architectural change is really a technological attempt to sort of bake in that idea that meaning depends heavily on the situation.
You could say that. And it directly tries to tackle the grounding problem. That combination, that confluence of symbolic clarity and subsymbolic fluidity, it potentially allows for better abstract general categorization and crucially makes it easier to transition between different domains or topics. The system isn't rigidly locked into just one set of predefined rules.
Interesting. Okay, let's pivot now to the other side of the coin, the more philosophical side of the solution. Our sources pointed out something interesting about how we interact with AI, that we often adopt what's called an intentional stance. We sort of treat the machine as if it's rational, assuming its understanding is like ours. Why is that approach seen as, well, potentially dangerous?
Well, it's mainly because it can be an explanatory failure, you see. When we just apply that intentional stance, we kind of overlook the specific, very non-human context in which the AI's output was actually constructed. We end up treating its output, which is really based on statistical probabilities, as if it represented human-like belief or actual intent, and that's misleading.
Can you give us a really concrete example? Where does that failure, that intentional stance, become genuinely high stakes in the real world?
Oh, sure. Consider using large language models in, say, preliminary medical diagnostics or summarizing patient notes.
Okay.
If a doctor or a nurse uses an AI tool to quickly summarize a patient's complex history and the AI hallucinates, maybe it invents a critical past medication the patient never took or misses a key comorbidity.
Right.
The clinician, maybe subconsciously applying that intentional stance, assumes the AI intended to provide accurate factual information. If they trust that output simply because it sounds confident and plausible, well, that subtle, ungrounded error could have really serious implications for patient care.
Wow. Yeah.
The real danger is that this kind of over-reliance can induce people to, frankly, trust the unbounded machine more than they perhaps should, especially in sensitive areas.
Okay, that really underscores the need for that second proposed solution path, hermeneutics.
Exactly. Hermeneutics. It's a branch of philosophy that directly challenges that kind of reductionism we were just talking about.
How so?
It really champions the fundamental importance of context and interpretation for meaning. It stresses that things like subjectivity, temporality, the fact that understanding happens in time, and the interpreter's own situatedness, their background and perspective. These aren't just noise or bugs to be eliminated.
They're essential.
They're essential elements in actually defining the meaning of actions, texts, concepts.
Yeah. So instead of striving for some kind of abstract, purely objective, scientific view of meaning, hermeneutics says, no, you have to integrate the interpreter's viewpoint, or in this AI case, maybe the machine's specific computational context, into the whole meaning-making process itself.
That's the core idea. And interestingly, this philosophical concept is precisely what those hybrid architectures we discussed are trying to implement, but structurally, technologically.
Oh.
Well, you can see the attempt to create a kind of computational representation of the hermeneutic circle.
Okay, unpack that connection for us. How is a hybrid cognitive architecture like CLARION an attempt to implement the hermeneutic circle?
Okay, so the hermeneutic circle is this idea, it's a recursive process. To understand any individual part, like a word or sentence, you need some understanding of the whole context it belongs to.
Right.
But to understand that whole context, you have to build it up from understanding its individual parts. It's a circle, a back and forward.
Okay, part to whole, whole to part.
Exactly. And in a model like CLARION, you see that reflected directly in the architecture. The system is constantly moving recursively from the whole representation, like the abstract high-level context of the interaction, back down to the specific inputs, the low-level symbols, the grammar, and then back up again.
Ah, so that layered structure, that top-down, bottom-up flow we talked about, is the mechanism trying to bridge the gap between just predicting syntax and actually achieving contextual interpretation, by making the machine constantly check its parts against its working hypothesis of the whole context.
Precisely. It's an explicit architectural attempt to move beyond just grammar and link a word's meaning, down at the lowest layer, to some kind of abstract conceptual representation up at the highest layer. It tries to make context absolutely central to the process, not just an optional add-on.
Right.
And this interaction, this sort of reciprocal exchange between the philosophical approach, hermeneutics, and the technological architecture, hybrid systems, that's really what our sources are pointing to as the most promising path forward.
And this merging, this reciprocal enrichment that leads to the ultimate goal, which the source's term Sophimatics.
Yes, Sophimatics. It's basically the perspective that emerges when you merge AI development with interpretative philosophy.
Yeah.
It's this recognition that, look, to get truly meaning-aware AI, the AI field itself has to fundamentally reevaluate core concepts like interpretation and understanding, but within the specific context of computation.
So we're not just building tools anymore.
Or we're potentially integrating deep philosophical structures and questions right into the fabric of machine learning itself. It's a shift in thinking.
What might that mean, practically, for how we define interpretation in computational terms in the future?
Well, it suggests interpretation can't just be defined as, say, a simple lookup function in a database. It has to be seen as a more dynamic process, maybe even one of negotiation between different possible meanings, reflecting that contested nature of meaning we see in human language. Sophimatics aims to push AI development away from just optimizing functional performance, like predicting the next word accurately, towards something closer to genuine conceptual understanding. And the advantage is it potentially advances both fields. Interpretative philosophy gets new test beds, and AI gets deeper theoretical grounding.
The goal being machines that aren't just intelligent in a statistical sense, but maybe truly holistic in their comprehension.
That seems to be the long-term vision, yeah. Truly meaning-aware.
Wow. Okay, what a fascinating journey we've taken. We started with that foundational failure of the old static, rule-based systems that couldn't cope with the messiness and ambiguity of real language. Then we identified that core technical roadblock, the ungrounded symbol problem, the hallucination issue.
Right.
And then we explored this dual pathway emerging as a potential solution. On one side, hybrid architectures offering a technical implementation, and on the other, the philosophical grounding provided by committing to hermeneutics, to context and interpretation.
The why and what,
Well,
yeah. And if we just step back for a second and connect all this to the bigger picture of AI development, it really presents a fascinating, maybe even daunting challenge for the next decade or so.
How so?
Well, one of the powerful claims coming out of our source material is this. Right now, there might actually be more to the philosophical considerations than to the purely technological ones in this whole pursuit of truly meaning-aware AI.
Wow, okay. That is a deeply provocative thought to end on.
Isn't it?
If the real key to solving hallucination, to cracking the grounding problem, lies less in just building bigger models or faster processors, and more in figuring out how to define computationally what it actually means to understand context, well, where should the bulk of our collective research effort really be focused?
A question to ponder.
Indeed. Food for thought for all of us as this deep dive continues.